Okay, so this is a video to go along with Module 2, Slides Part 3, that utilizes multiple regression. I am just going to do the example that's given in the slides, and that's here on Slide 5. The nursing instructor wishes to see whether a student's grade point average and age are related to the student's overall score on the State Board nursing exam. Ordinarily, and this is a textbook example, you would never do a multiple regression with 5 data points. However, it's a toy example from a book, so just be warned that, with a really small data set, it's not enough. You really need to have at least 20 observations and probably 40 or more to be doing this. And so the book has already produced the model. It's right here. This is from the Blumen book, somewhere in chapter 10 toward the end. The y prime, that's the predicted state board score, is negative 44.81 plus 87.6 times x1, which is the GPA, plus 14.533. So I am going to reproduce this model by running it in SPSS. Okay. And so the data for this is the nursing data set. I think I entered the data correctly. And we are going to do a regression where age and GPA are the independent variables, and score is the dependent or y variable. And so we're going to do this just like we did simple linear regression. We're going to go under Analyze. We're going to go Regression, Linear. Okay. These are, there's a whole bunch of other fancy linear regression and non-linear regression type models. So that's what all this other stuff on the menu is. So we go here and we click the score. Okay. And the dependent variable is the score. That's the y variable. The independent variables, we're going to enter both GPA and age. Okay. Now, there's this thing here called method that we haven't talked about before, because it doesn't... Method, when you're just using one variable, method, there is no method. It's just one variable. Method refers to how the independent variables are selected, because you may or may not want to keep all of the independent variables in the final model because they might not be significant predictors. And so there's a variety of methods that SPSS can use. We're just going to look at enter and stepwise. Enter simply means we're just sticking them all in, and we'll talk more about this later. So in this case, there's only 2 variables, so there's really not a whole lot going on there. The only other thing I do want to look at is I want to go under statistics, and I want to select the R-squared change. Okay. And then I'm going to hit go, and then I'm going to hit OK, and then we're going to look at the output. Okay. So the output is here, and it's a summary of the variables entered or removed. So we have age and GPA. Those are the requested variables. The method is just stating the details of the model and how we entered it. And then we have down here, this isn't entirely what I wanted. Wait a minute. Okay, I don't want residual statistics. Hang on. Let me just read this. Okay. So I want to look at analyze, regression, linear, and then this, and then statistics, and then the R-squared change, which I'm not actually getting. I don't want the model fit. I really don't want to look at that right now. Let's see what happens. Oh, never mind, because it's enter. I'm looking at this model summary, and I'm looking at R-squared change, and I'm thinking that there should be more than one R-squared value in here, but there's not, because when we do enter, it's just throwing all the variables in all together. So anyways, this really isn't going to be of much interest. The R-square is 0.979, and it's not actually going to change because we're only running this model once. And so this is the model output. The R-square is very high, so there's a lot of prediction going on between age and GPA being responsible for predicting score. The coefficients are down here. Now, these right here, you want to look at the unstandardized beta. All the standardized mean, by the way, is they're very similar to standardized scores in any other situation where instead of using a score with a unit, you're dividing by a standard deviation and you get a unitless beta, but we don't necessarily want those in many cases. So always just go by the unstandardized betas. That's what the book is doing. So back to the slide, the coefficients are negative 48.81. Now this is an intercept of sorts. This geometrically, this is a plane. It's a best fit plane through x, y, and z. Theoretically, the two variables. In this case, GPA and age are basically x and y, and z would be an outcome. I know we usually think of y as an outcome, but so, I mean, really, we're fitting this best fit plane. So let's look at these coefficients versus the ones that we got. So we have 48.81, and that is this value here. And then we should have 87.6 and 14.5. And we do. So I have just reproduced this model right here in SPSS. We also want to note whether or not the coefficients are significant. And they are. Now this first thing, again, this is an intercept term. It doesn't really matter whether this is significant or not. We're looking for the significance of the actual predictors, which are the GPA and the age. And the p-values are both less than 0.05. So we have two significant predictors of our outcome score, and this is the simplest way to run a multivariate regression in SPSS.